Alright guys, today we're going to solve log and exponential functions. So sticking with what we know, okay, we can rewrite this as an exponential function. We can say the base 16 is raised to the x power is equal to 1/4. Now what we're going to do is we're going to try to write these as the same base, right? So 16, I can write that as a base of 4. So that'd be 4 raised to the second power, and that's now raised to the x power. So 4 squared raised to the x power is equal to 4 raised to the negative 1. Now, if we have a power raised to a power, we can multiply those, so we get 4 raised to the 2x is equal to 4 raised to the negative 1. All we got to do, if we have the same base, is take our exponents and set them equal to each other, so 2x equals negative 1, excuse me. Now I'm going to solve for x, so x equals negative 1/2. Alright, looking at number 2, same thing. I've got 9, I'm going to raise it to the 5/2, and that equals x. Alright, so you've got 9 raised to the 5th, and the square root of that, which x equals 243. Now, number 3, if we have the same log base, we can say this is equal to this, right? So 3x minus 5 is equal to 2x plus 4. The log base 5 and the log base 5 cancels out in the same way that we have the same basis here for an exponential. We have the same logs, then they cancel out. So now we're doing solving an equation. We're going to move 2x to this side, we're going to add 5 to this side, and we get x equals 9. Here I'm going to say log base 4, so 4 raised to the third power is equal to 4x minus 16. 4 raised to the third is going to give me 64, so 64 equals 4x minus 16. Now let's add 16 and solve for x, so 80 equals 4x, so x equals 20. Flip it on over to it back. Alright, we've got the log base 3 of x squared and the log base 3 of x plus 12. Again, same log bases. I can cancel those out, so I've got x squared, the argument, equals x plus 12. Now what we're going to do is we're going to try to factor this quadratic. So I've got x squared. If I move this x over here, it's going to be minus x. Move the 12 over here, it's going to be minus 12. That's equal to 0. So I can solve that quadratic a number of ways. I'm going to go ahead and factor it. So factors of negative 12, they combine to give me negative 1. It's going to be x minus 4 and x plus 3. So we get x equals positive 4 and negative 3. Looking at number 6, log base nothing, which would be base 10 if it's not written. So the log base 10, so 10 raised to the third power is equal to x plus 7. 10 raised to the third is 1,000 equals x plus 7. So x equals 993. Looking at number 7, okay, I've got 4 raised to the x minus 5 equals 16. Alright, so again, we want to rewrite these as the same base, right? So this is a base of 4, so let's rewrite this as a base of 4. So we've got 4 raised to the x minus 5 equals 4 raised to the second power. That's what 16 is. So now I've got the same base, those cancel out. I've got 2 equals x minus 5. Let's add 5 to both sides, and we get x equals 7. Same thing here, I want to get the same base, so I could rewrite this 27 as a base of 3. I could rewrite the 81 as a base of 3. So this 27 is a base of 3 raised to the third power, and that's raised to the x. This 81 is a base of 3, raised to the fourth power. Now again, this 3 raised to the third power raised to the x power, so power raised to a power you multiply, so 3 raised to the 3x is equal to 3 raised to the fourth. Same bases, those cancel out, and we get 3x equals 4. So then we're going to go ahead and divide by 3 on both sides. We get x equals 4/3.